Good morning, everybody. So I'm going to do this screencast here for our remote day students. So for remote day, we're not going to be meeting in person, obviously, and I won't be able to interact with you during the class. So you're going to have to be figuring everything out from the website today. So this is for today is going to be for Monday or Tuesday for the week. And you guys want to start off with your first classroom. So this is for block 3, but this is going to be the same lesson for block 4, just so you know. So we have our regular calendar here under our physics class. You go into our classwork tab, and we still have all of our regular set up here with our slideshows for the day. So what we're going to be looking for today is going to be for the remote day slideshow. You guys can open that up and also open up the calendar. There's a couple things to notice on the calendar today. We have got the remote day is going to be the second one here. So you can notice right here it says 125, 126 remote. Okay, whereas this one says in person. So you're always going to go for that remote day lesson. And we're going to go ahead and we're going to do some reading comprehension today. We're going to be looking at some Khan Academy, and we're going to begin doing a lab that we'll be working on for a few weeks called the Rocket Lab. Also, the homework is right over here, so you can kind of see where the Khan Academy is. I do want to mention that the videos in the Khan Academy are optional. Okay, so if you feel like based on the lesson that you can do just fine with the Khan Academy, don't worry about the videos. But if you're struggling and you're not getting 10 points on those things, you want to go ahead and make sure that you watch those videos, try it again, and maximize those scores. You always will get the highest score on Khan Academy. The work and energy reading comprehension link, that's going to be due by Wednesday at 8 a.m. And then also, we're going to be doing this lab. And I want you guys to get yourself a 2-liter bottle, duct tape. And once you look through the lab, you'll see there's some other materials you might need, like cardboard or plastic or things like that too. That's going to be up to you with your design. And we'll need those things by Wednesdays because our next remote day, we're going to be building a rocket at home. Okay. Every day that you're in remote, I'm going to be doing attendance through this attendance form. So you can kind of see what it looks like over here. So it's real simple, just first name, last name, what block are you in, what did you work on today, and what do you have left to do? So just kind of a reflection on the week there. So take a look into our calendar, I guess. All your links are right here. So we've got the attendance form link. We also have that embedded in the slideshow. I'll show you that in a minute. We have all the links for the assignments right here, including the Rocket Lab. Okay, so getting into our slideshow for today. So this is going to be our remote slideshow. You can kind of see the lesson here. And actually, I'll put the word remote in here. Okay, so to just get that real obvious for you. So this is going to be our remote lesson right here. Awesome. Great. And so I'm going to go ahead and mention that the form for attendance here, I want you to do at the end of class, so not at the beginning, because it's a reflection on what you've done in the class. Right? As far as formulas go, get out your formulas. You'll need them for today's lesson. And we're going to be working through a new topic today. So this is going to be subtopic 2.3, work, energy, and power. And I've got the formulas highlighted for work, energy, and power. You'll read about those today, and it'll help you think about your Rocket Lab design. The other thing that I put in the slideshow today is these energy notes here. Okay, so you can kind of see work and power notes and EPE notes. These are supplemental notes, and they're just an additional resource. So when you're working through practice problems, you're not understanding something really well, just kind of thumb through those and look for some updated notes that will help you understand what's going on. So again, we're in this idea today of the hybrid schedule now. So we're back into the school mode, like in-school person instruction. The A cohort people come in Mondays and Wednesdays. The B cohort people come in Tuesdays and Thursdays. And you guys work remotely on the other days. The students that are 100% remote will act like an A cohort student. They're going to attend Zoom on Mondays and Wednesdays. Okay. All right. So here's your link to your reading comprehension. It goes along with the online textbook. The link for the textbook is within the actual reading comprehension. Khan Academy videos are optional. Get into Khan Academy. You'll see the assignment there for you. Okay. And so getting into the start of this unit about work, energy, and power, I've got an introductory video that's going to go through the main concepts. There's some questions, and I put these as thought questions. You could go ahead and jot down answers as they go through there in your journal. I'm not going to grade it, but it's something I just want you to be able to sort of hold some thinking as you go through. And you're going to take these ideas in with you. You think about your rocket design that you're going to work on here next. Okay, so once you get that basic feel for, well, what is this whole work, energy, and power thing, we're going to be testing that with a Rocket Lab. Okay, and so you're going to want to read through this. But so here's the Rocket Lab in general. So today you're going to explore what the Rocket Lab is. It's using concepts of work and energy. Next remote class, you're going to build a water bottle rocket with a 2-liter bottle. You might need to get like a 2-liter bottle of Coke or something like that and have everybody in your family drink some of it, even though it's totally unhealthy. Or you go for the healthy version, maybe get some water in a 2-liter bottle. But yeah, we need the bottle. That's the main thing. We're going to be going outside on Monday, Tuesday of the following week. I think it's February 1st, February 2nd. And we will be launching those rockets and filming them and doing video analysis with them. So again, the homework is to get a 2-liter bottle, duct tape, and that's going to be due by next class. For remote students, I'm going to provide data on the rocket with videos and everything for you. And so you won't be building a rocket unless you decide that you want to. Okay. And what I'll do is I'm going to go ahead and get one of my rockets that I have at school from past years, and I'm going to give you the data and send it to you with pictures and stuff like that. But if you decide that you want to build a rocket, okay, which would be great, if you could deliver that rocket to me by this Friday, so it's in school, I'll watch it and I'll film it and I'll give you the film of the rocket being launched. Okay, so just keep that in mind. You can do it if you want. You can email me or go into Google Classroom comments and talk to me about it too, and we can set that up. Okay, so read through this Rocket Lab. This is going to be going on for a few weeks. There's a lot of stuff going on in here, but I want you to read through the actual lab itself. It's right in here. And when you click this link, we're going to go ahead and open up. This is for Block 3. Block 4 is in there too. But in the link, there's 2 things inside this assignment that I want you to check out. Okay, the first one here is the Rocket Lab document. So this just shows you everything you need to do. But this other one here just says Rocket Lab, and it's a blank document. It's literally completely blank. Okay, but it's every student gets their own copy. I want you to type your lab in that blank document. Okay, that's going to share it with me the whole time you're working on it, so I can see your progress, and we can do like checks in there and stuff like that. So I'm going to have you do all of your work inside this blank document. That's where you're going to get started. All right, so excellent. So getting back into our show. So some of the things about the Rocket Lab, it's using what we call the work energy theorem, which we're going to be learning all about the science around that. We're basically putting work by pumping a pump into storing that energy that we get from the work we put in there into the rocket in the form of pressure. That pressure is stored energy inside there, and it ends up releasing and pushing the water below and then pushing the rocket up, and it turns that potential energy that we've stored inside the rocket with pressure, and it turns it into kinetic energy, which it leads to high velocities, which leads to high height. It goes up really far, which is another type of energy that we call gravitational potential energy. So we're really just going to be tracing through energy transformations. And the goal here is to build an efficient rocket. So you're going to be doing some research now to figure out, well, what types of things, nose cones, weight in the nose cones, fins, things like that, aerodynamic kind of characteristics, what makes for an efficient rocket? And you're going to be testing out that hypothesis of if the features that you make are chosen for your rocket, will that lead to a highly efficient rocket compared to your peers? And we'll get to see at the end like how their designs compare to your designs, and then how that compares to the efficiency of the rocket at the end. All right. So some general instructions. You're going to be doing research and citations. And so you're going to be looking on websites and looking up different ways to figure out what would be the most efficient rocket. You're going to type up a lab report. You're going to design a rocket, and you're going to collect data related to its performance. And then we're also going to be recording a launching event and doing a detailed video analysis of a rocket launch. Okay. Now, as far as the lab write-up goes, you've got all these different pieces. This is kind of following through a general lab format, and you would want to follow a general format like that for your lab too. Now, when it comes to designing the rocket, this is what you're going to do next class. Notice that I've got an example, so you can click this and it goes through and it talks through like how to build a rocket with like a website with like steps and stuff. Now, just one thing to note, I have the equivalent of the cork that they show you in there already built, so you don't need to build a cork. I have that already. But otherwise, the rocket that you see in this picture here, you're going to want to have all these features. And so you're going to notice that you want to build some sort of nose cone, maybe out of cardboard or plastic or some other thing that you can find. You look on websites, you'll see there's different varieties of that. But you're going to put that on there. You're probably going to put some weight in the nose. You want to have your rocket so it's top heavy. It's going to make it much more stable in flight. Okay, so you could put something like sand or rocks or clay or some kind of ballast, they call it ballast, it's weight, inside the nose cone. You're also going to build some fins that you need to attach to your rocket. And when you attach it, make sure that you never cut the bottle. This bottle needs to hold a significant amount of pressure, and so it needs to have a lot of integrity. And the other thing is, don't hot glue anything to the plastic. Hot glue, it actually kind of partially melts the plastic and it makes it brittle, and it'll make it break when we put pressure in it. So you don't have to duct tape these fins onto the rocket. Just use duct tape, just like duct tape the nose cone on your rocket too. And you can cover the whole entire rocket with duct tape. I recommend, like, for the beauty and appearance of your rocket, to get yourself some nice looking duct tape and do some cool patterns on there. Then you can paint it, you can use Sharpies, you can make it original also. Next thing is this part right here where you have the nozzle for the bottle, like where you'd pour the drink out of. Don't cover this piece with tape, because this whole chunk right here, I have an apparatus that squeezes on there and holds it onto the launch pad and then lets go. And so there should not be any tape on this spot right here, like on the end of the nozzle. Okay, so that's the main things to keep in mind. It's got to be a 2-liter bottle, okay? No 1-liter bottles, 2-liter bottle. All right, so that's going to be not today, but you're going to build that on Wednesday and Thursday. Okay, whichever is your remote day. Now, there's additional resources here, and you can cite these resources, by the way, in your lab report. But these are just some other resources showing you building and launching of water bottle rockets. So you get an idea of like what we're doing, basically. So kind of check those out. And then the last little bit, this is for today's work. I want you to actually open up your blank Google document in Google Classroom, when I showed you earlier, and begin the process of researching how to design your rocket to achieve maximum efficiency in the flight, and collect research and citations beginning with your bibliography. Start to begin your bibliography. So start to get those resources and put them in that lab and hold them there for now. And we're not going to do a lot of typing yet, because we're going to get to that soon, but think about the methodology that you're going to use to build your rocket, because you're going to want to type that out as a methodology procedure kind of section with materials, and take into account your research as you work through that methodology and what variables you need to control to make sure that your rocket launches well. You want to have all of your materials gathered so that next remote class you can build your rocket. And then it's essential that you have the rocket in school when you come in on Monday or Tuesday. And again, I mentioned with Road Kids, if you guys want to do that, come in by Friday and drop it off by Friday, and I'll actually launch it for you too. Okay, so that's pretty much today. So just to kind of summarize everything, got things to think about. You want to do a little bit of this background research into work, power, and energy through the Khan Academy and the reading. And then also there's the video to give you some basic information so you know what's going on with the science around this bottle rocket. And then you want to get into the bottle rocket, start doing some research into it, and then start to gather materials for the building of the rocket next time. The end of class today, it's important that you do the remote day attendance form. That's how I'm doing attendance. And that's it. So look forward to seeing you guys in school next time. Have a great day, everybody. Bye.